All right, folks, the best way to figure out whether something makes sense is to look at a bunch of different real life examples and see if we can figure out what the positive and negative signs mean in physics. So let's get started. First, you're going to watch the trapeze video and then answer some questions. All right. Once you start translating word problems to pencil and paper, one thing that I highly recommend you do is draw a positive and negative sign on your diagram of what's going on. And the trapeze artist was, so there was a trapeze you couldn't see, and the trapeze person jumped into this net. Their velocity was downward. So we represent that with an arrow pointing down. And it doesn't really work here because I didn't have space, but you can, in general, you can see that the velocity vector is pointing to the negative sign, which is another hint that that value is negative. We don't know this yet, but forces, pushes or pulls, cause acceleration. And so the net is clearly pushing up on the trapeze person. So that push is up. So since the force caused the acceleration is also up, and the acceleration is therefore positive. So what's a little bit tricky is that this person is slowing down, and yet the acceleration is positive. But that's because acceleration in a positive, negative sign in physics for acceleration does not mean loss. It means direction. So the velocity is down because the direction of our motion is down, and the acceleration is up because the direction of the push is up. All right, now you're going to watch a swing set video of a person, according to their dad, trying to make friends at the park. All right, so I'm just going to call this person Friendly. So when Friendly pushes swing number one, their motion was to the left, so that's negative. Friendly was pushing swinger number one to the left, so their push was negative. And so the velocity is negative and the acceleration is negative. But I hope that it makes sense that the person on the swing was speeding up because they were getting an assist from their friend. So this is what I want you to note. In this case, the push, and therefore the acceleration, is negative, but the person being pushed is speeding up. Okay, and then when friendly person on the ground, in my mind, when they tried to push on person on the swing number two, they started to, push a little too soon. So swinger number two was headed to the right, which was positive, and little friendly person was pushing to the left, and so the swinger actually slowed down, so that might make sense, right? Oh, I'm moving, my acceleration is negative and I'm slowing down. Okay, so just looking at some looking at different examples to identify direction of velocity and therefore the sign, direction of acceleration and therefore the sign, and see if you can figure out, is a rule. It's not negative acceleration means slowing down. See if you can figure out the rule. Okay, now you're going to watch the golf ball video. So the golf ball, there's two segments in segment number 1, the golf ball was headed to the right, and therefore it has positive velocity, but the wall was pushing on it to the left, and therefore it had negative acceleration. And the golf ball was slowing down. Yay. The golf ball came to rest, but so it squished and squished and squished, and then at some point it started to unsquish and change direction. And so now the golf ball's velocity is headed to the left, which means it's negative. The wall is still pushing to the left. And if you think about what's happening to the speed of the golf ball, it was 0 for a split second as at maximum squish, and now it's unsquishing to the left, so it is speeding up to the left. So even though the acceleration is negative because it's pointing left, the golf ball is speeding up. Oh my God, why is this so confusing? Why do you have to make this difficult? All right. There is a pattern. There is a rule. It's just not the rule that you've spent most of your life thinking about, in that because in most of your everyday life, negative sign means loss. Okay, so there are rules. You just got to learn new rules. I promise you'll get this, but it is tricky. Okay, so if your position is negative, it just means you're to the left of whatever you decide the origin is, or you're below whatever you decide the origin is. Okay, it's your relative location. It's the direction you are away from the origin. Your velocity is negative. It means you're moving left or you're moving down. This is the tricky one. If your acceleration is negative, it means you're being pushed to the left or being pushed down. All right, and so here's a chart of everything that could happen. I'm not going to read all of this in the interest of time. You can pause the video. If you want to copy this to your notes, that might be helpful. See if you can figure out the rule. It is not negative acceleration means slowing down. All right, moral of the story. If you want to make friends, then the velocity and the acceleration, if they have the same sign, then you're being pushed in the direction that you already are going, and you're going to speed up. And if the velocity and the acceleration have an opposite sign, then you're being pushed in the direction, you're being pushed opposite the direction you're going, and you're going to slow down. Okay, so there is a rule. It's just not the rule you think it is. All right, we're going to do a couple of problem-solving hints, and then we're done. The reason I'm making a big deal out of this is because the word problems are not going to say the car is going to, it has a negative 15 mile an hour velocity. They will say the car is headed west at 15 miles an hour. Okay, so you have to know when to put the minus sign in. So you should draw a picture. You should put the plus and minuses on the diagram. That's why I did it on the embedded screenshots. And just think of your X and Y axis, right? Think of the coordinates. Up is positive, down is negative, to the right is positive, and left is negative. All right, the word problems will not include the sign of the acceleration. They will not, and they will just say the car's headed west at 40 miles an hour and is slowing down, or west at 40 miles an hour and is speeding up. Or that's one of the things you will calculate, like we'll do in the lab activity tomorrow. You'll calculate A, but I want you to be comfortable when you get a positive A, knowing, oh, I have a positive A because I'm speeding up forward, or I have a positive A because I'm slowing down backwards. All right, this is your workflow, the order in which you should make the decisions. Draw a diagram. Draw what's going on. It's going to help you. Label your positive and negative. You know, to the right is positive, and up is positive. It's going to help you, I promise, even if it seems silly. Then decide on the sign of the initial position. That's pretty easy if you're to the left or the right. I forgot to put that on there. Then decide on the sign of the velocity based on whether it's going left or right, or up or down. And if you know it's going left, which means negative velocity, and slowing down, then you slap that minus sign in front of the acceleration. So it helps to have the velocity locked in place first so that you know whether your acceleration needs to match that sign or not match that sign. Does that seem confusing because you didn't see an example problem? We will do tons of example problems. I just wanted this vocabulary in the back of your head as we start to do examples and you start to do the work, so that you have a conceptual reference. All right, thanks for listening, and I'll see you in class.